Hello learners, greetings of the day. I am your trainer Abhishek Ray. In module 4.2, we will learn about route optimization and cost control. The learning objective of the overall 4.2 module would be to understand the science of route optimization, and then we understand what are the transport cost control strategies. Then we arrive to the last mile challenge of delivery. And finally, the most important, customer service and logistics KPI. Let's begin. In the previous module, we learned how goods move, how they move from one point to the another. In this module, the focus will be to learn how to move goods better, cheaper, and in a smarter way. Transportation cost is one of the largest controllable cost in logistics. Please underline this what I'm saying. Largest controllable cost. That means it 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 has the potential to control a huge amount of cost that impacts business. And that is why it becomes very important. Even a small improvement in routing, or in choosing a route, or the last mile delivery being done in a perfect way can save lakhs or crores for companies. Just try to imagine mm, a particular travel logistics truck moves from point A to point B, which is roughly around 100 kilometers. And this travel it does every day, month after month. And if there we can ensure that the fuel mileage or the fuel efficiency is derived at its peak or perfectly, just imagine 365 days how much amount of cost it will save to the company. And on the vice versa, if this 100 kilometers is traveled in a way where the fuel efficiency has either been overlooked or has not been managed properly, that means the truck is consuming excess fuel over there. Just imagine the loss will be in the tune of lakhs and crores on just this one particular route. And that is why this is very important to understand that transportation cost has very high impact on businesses. The science of route optimization. What do we mean by that? Route optimization means, you can take a cue from the word optimization, optimizing things to the most desired level, right? So route optimization means deciding the best possible path for delivery vehicles to follow. Now, the best, do not get confused with the word best. The word best does not always means the shortest distance. Yes, you have heard it right. The shortest distance will not always be, can be, but will not always be the best possible path. The best possible path usually means the one that requires lowest cost, that is achieved in the least time, that consumes the least amount of fuel, and above all, that ensures that it achieves maximum number of deliveries. In today's world, when the businesses are growing, movement of products are increasing, customer demand is increasing, the efficiency and the optimization is best achieved when the logistics company achieves maximum number of deliveries per day or maybe per hour, whatever, but the delivery should be maximum. So route optimization is about making smart trade-offs. Why am I using the word trade-offs? Because it may so happen that you know that you are taking a longer route, but at the same time you know that because of low traffic, that longer route results in least time. So that is where the trade-off happened. Although you traveled a longer route, but then you reach there faster. For example, a slightly longer route may avoid traffic, right? You may have two options. One route from point A to point B, you may have two options, route number one, route number two. Let us consider that route number one is a longer route and route number two is a shorter route. But the shorter route actually goes through the city, and that is where traffic congestion happens. That is where more and more petrol is consumed. So this is one particular example where possibly taking the longer route avoids traffic, and that is why saves fuel, and also in highest probability also saves a lot of time, and that is why that route becomes a better choice even though it is not a shorter route. Okay, just it is very obvious that a vehicle which spends a lot of time idling in the traffic also results in a lot of high petrol consumption, and that is where the concept of efficiency over distance comes in. That is where you understand that efficiency becomes more important over the distance that is being traveled. Now let's look at another concept. You may have heard about this complex term called as the traveling salesman problem. You can find it out there in the internet. Its short form is TSP. Let us try to understand in a very simple manner what is this traveling salesman's problem. Take an example, a salesperson. A salesperson typically will start from one location at the start of the day. That location can be from his office, reporting office, can be his reporting area office, can be from home, depends from company to company, depends on the kind of product that he is selling. But he will typically start his day from one location, but then he will visit multiple customers. That is where his efficiency becomes. See, in sales, it is one thing one must remember. Not all sales meeting or all sales call result in your actual sales. So to achieve your target, you need to do a lot more customer meeting. And that is where the salesman's problem comes in. He starts from one location. To achieve his sales target, he has to meet multiple customers, visit each customer only once, and return back at the lowest possible cost or distance. But this is easier said than done. Try to understand, try to visualize it. A salesperson starting from one particular point in your city has to visit 20 different customers in their different houses. Is this so simple, going from one point to the customer and then coming back? No. And that is where the traveling salesman problem comes in. That is where the salesperson needs to manage his visit in a more efficient way. In logistics, delivery vehicles face the same problem as the salesperson, and this they face every day. Example, a delivery van must visit shop A, shop B, shop C, where that delivery van will be delivering the products to the retail outlets, to the shops in this case. There are multiple route combinations to go, whether he should go to the shop B first or to shop A first, or maybe shop C first and then to shop A, multiple combinations, but only one will be the most efficient one. Now, here in this example, I gave it in a very simple manner, shop A, shop B, shop C. But life and actual business is not so simple. Manual planning will work in this case where there are only 3 shops to be visited. So I can very easily understand which is the near part to me. So I'll first deliver over there. Do I have a highway which will make me reach to that particular shop fast? I'll also consider which time of the day I'm traveling, when the traffic is at peak, when the traffic is at its low, so that I can plan it efficiently. But when the stops become 30, 300 or more even, then companies need a system. Companies need a logic, because this is where guesswork and manual planning does not work. And that is why route optimization exists. Optimization is a very, very scientific model which helps companies decide when the complexity is there of achieving more number of customer visits or delivery visits in one particular day. Now let us understand two very important concepts in this entire subject of route optimization. What are the options that a company has? The first option that a company has is direct delivery. As the word suggests, direct delivery means one vehicle straight away takes one trip and reaches to one particular destination. Very, very simple. Advantages, as I said, simple. Of course, very fast. It will be very quick. No stops, no thought processes to go here, stop there. It's very fast and requires very less coordination. Disadvantages, it is again has a high cost, because the vehicle utilization in this case is very, very low. The truck goes from warehouse to one retailer, empties itself and comes back. So while it is coming back, although it is a non-productive work that it is doing, because now there is no delivery involved, it is just coming back, but the fuel is being used at the same rate it used while it was going to deliver, and that is where it becomes disadvantages. Also, in my opinion, in all the practical or in all practicality, seeing today's world's business scenario, this delivery, direct delivery, hardly ever works, and especially if it is a high movement product where there is a lot of delivery, direct delivery option is absolutely out of the books. The next concept that comes in is a very interesting concept, and that is being very, very commonly used by most of the logistics company today, and that is the milk run concept. It is inspired by how milk is collected from villages. I'm sure this might be, you might have seen this in your country also, from where you are listening to this lecture. You might have seen, if it's not from milk, it can be from some other dairy product also, but I'll talk here regarding milk. Milk is typically collected from villages. One vehicle follows a fixed route, makes multiple pickups. It will straight away start its destination from A to B, and while following that route, there will be many, many pickup points, A1, A2, A3, finally it reaches to B. Delivers, returns after completing the loop. The advantage is better vehicle utilization. It was not going for a one point delivery. It delivered and picked up from multiple points, and that is why cost per delivery in this particular scenario becomes very, very low. It has also a benefit of being more predictable while scheduling, although it also comes with its own disadvantages. And what are they? It requires a lot of planning, a lot of planning. It also takes longer delivery time. It is never the quickest option. But yes, again, if you remember, if you recollect what I said, route optimization is about making smart trade-offs. In this particular scenario, if time is not of essence, then of course time can be traded off against more lower cost per delivery, better vehicle utilization. Milk runs are ideal when, as I was saying, ideal when volumes are small but the frequency is very high. Remember that the volumes are small but the frequency is very high, and when cost control is very, very important. If you have a product which runs on very, very, very thin profit margins, you would not like to spend much money on its delivery, and that is where you will use this milkman delivery concept. In traditional transport, a truck goes to one point and returns empty. This is called as deadheading. In the future lectures of this particular course, I will come to this very important point. As of now, I would request you to just keep this in mind. A truck goes to one point and returns empty. that is called as deadheading. As I said, it requires equal amount of fuel while coming back, but it is basically of no productivity that travel is being done. Optimization introduced, and that is why optimization has introduced the milk run theory. Instead of multiple trucks going to one supplier each, a single truck follows a circular route. And while covering that circular route, what it does, it covers multiple points where the delivery happens. And that is how the cost of delivery is shared by all those multiple delivery points. Picking up small amounts from several suppliers and delivering to the factory, that is what makes it very important. I'll give you an example. A car manufacturer in South Africa has 5 different suppliers for small bolts and plastic materials. Now, there are two choices. Either they can use 5 trucks who will travel to different locations, go to these different vendors, collect the material and come back to the factory or to the car manufacturer. Or the other option is one truck visits all of these suppliers daily and collects from them. What do you think? Which one is a more viable option? Yes, of course, timing would be more when it comes to one truck. If you could have used 5 trucks, then definitely it would have served, the material would have come much more faster. But then in my planning, I know when my bolts and plastics are required. Is time so important? I am not bringing those materials to manufacture a car today itself. My manufacturing is already happening in my assembly line. This material that is coming in is probably to maintain my inventory of bolts. So time doesn't become important. And that is where choosing one truck to visit all of them daily becomes much more cost effective. This increases significantly the vehicle utilization and of course slashes the fuel cost, thereby reducing the overall cost of transportation. We learnt about the science of route optimization and also the concepts like direct delivery and milk run concepts. I hope this session would be fruitful for you. Let's meet in the next session. Till then, happy learning.